Followed by Pilar Fernández, who will speak on assessing the human dimensions of human-tick contact risk using a smartphone application.
Thank you very much. So this is part of my research. So my research project that I'm undertaking here at the Earth Institute, it's about coupling natural and human systems of tick-borne diseases. And while we were developing the research, we realized that we don't have good methods to collect human behavior data and tick contact data. So we decided to develop smartphone application, which is going to be the focus of the talk here. So to give you a little bit of background on what I'm studying is, so I'm focusing basically on tick-borne diseases, but this can be applied for any vector-borne disease. So these are my previous insects that I study, which is triatomine bugs that cause Chagas disease. Now I'm working on tick-borne transmission, and this is the one that you find mostly here in the Northeast, which is the black-legged tick, and of course mosquitoes, which are the most studied vector-borne disease transmission. So transmission of these diseases obviously involve ecological factors, which determine where the vectors and the hosts are, the distribution of densities, and their contact rates. And obviously biological factors as the infectiousness to the vector or to the host, depending on which one you're talking about, immunity and all those variables. But we're also thinking about when it involves human populations, then we need to think about the socioeconomic factors, the psychological, cultural, and political factors that affect contact rates between people and these vectors. So in this framework, we have two different approaches that we can take that are related, which is the eco-health or eco-biosocial research, which integrates both of this all of these factors and their interrelation. So to basically move the previous framework into the coupled natural and human systems, we can identify that obviously on the human dimension of the disease, we can place the socioeconomic factors and all the other that are related to human behavior. On the other side, we have the ecological factors and biological factors, although this can also apply to the human system when we think about human immunity and different vulnerability to disease. But also, so we have these two systems that are obviously coupled through different processes, and the way they are coupled between the natural system affect the human system by transmission and contact rates. So in this framework, we study the dynamics within the natural system. We also study the dynamics between the human system and the feedbacks between both of them. So I try to apply this to tick-borne diseases. And basically, on one side we have the human system. Well, first I'm going to start talking about the zoonotic transmission cycle, which is being extensively studied for tick-borne diseases. And basically, I'm going to distinguish between the hazard and the risk. We talk about risk when we refer to people, and we talk about the environmental hazard when we talk about the ticks. So basically, the outcome on the zoonotic transmission cycle, if we think it from a human point of view, is the density of infected nymphs, which is the most infective stage of the tick that is the most risky for people. It's going to be the hazard, the environmental hazard. And people are going to get infected, obviously, the more density of infected nymphs there are, the most risk they're going to have, but also how they are exposed to those ticks. So the people are going to affect directly the zoonotic transmission cycle by interventions directly on their backyard or through other interventions like deer control, for example. But also there are other effects they're going to have through habitat fragmentation and changes in land use, which is going to affect directly the zoonotic transmission cycle by, for example, affecting host mobility, and also because they're going to change the host community composition. And obviously, like I said, the hazard, if this affects the density of infected nymphs, then it's going to affect how people respond. But also because we're talking about people and people adapt to different situations, we need to consider how people adapt and the adaptive behavior, because how they are exposed to risk depends on how people are behaving. Where are they going to be exposed to the ticks? So for example, here we have a gradient of urbanization and we can identify the different processes, the habitat fragmentation and the effects that they're going to have in the host community and directly on the matrix, on like basically what is the ratio between forest and urbanization, because it's right at the edge where people are getting exposed, or directly in the forest. And we're also thinking about different ways of human risk. So for example, in the forest it's also only recreational. So people are getting exposed to them when they go to forest and they go hiking, for example. And this is the most traditional setting for Lyme disease risk, which is suburban area, low intensity developed, and people are getting exposed mostly around their, in the peridomestic area around their yards. As we move into more urbanized areas, then we have patches of forest or parks that could be more or less connected, and then people are getting exposed to in their own yards, but also when they go to the parks. And you have the high intensity developed area where you don't really have a risk in situ, because you don't have parks, or the only park that you have, for example, here in Manhattan, is completely isolated, so you don't have that risk. And basically, we are studying this system on Staten Island, which will be this situation. And it's where Lyme disease is emerging now in urban areas, which impose a risk for people, because more people, the density of people living in these areas are higher than in the low intensity areas, and people are not really aware of what's happening. So focusing on this emerging urban areas, we want to understand what's the effect of the habitat fragmentation on the environmental hazard, and how connectivity between parks affect the density of ticks, basically, and what's the dynamic with people, how are ticks getting to people's houses. And that has to do with deer mobility. So the deers are the ones that are bringing the ticks into people's yards, and we think that the hypothesis behind everything is that there is a source-sink dynamic. So the ticks are in the parks, which is the source, and then they transport the ticks into people's yards. But for people to get in contact with ticks, we also need to understand what they do if they go to the park, where are most at risk, in their own yard or when they go to the parks, and how their knowledge, attitudes, and practice affects the human-tick interaction, and how they change over time based on their experience with ticks. And for this second aim is that we develop the app, but I'm going to talk a little bit more about it. So the idea is that this information from aim 1 and 2 is going to as input for an agent-based model, where we're going to be analyzing how people change the contact range and how it changes over time. And basically it's going to be a platform to try different interventions and how can they affect and what's going to be the outcome. So basically on Staten Island we decided to analyze the peridomestic risk or urbanized landscape, the human behavioral risk factors, and the knowledge, attitudes, and practice, like I mentioned. And for this, we developed a household survey. We visited 500 houses, and we analyzed the yard features that are associated with with human exposure. We did tick tracking to see the density of ticks in people's yards. in human activities and movements through the tick app, and we also did KAP surveys. Why did we decide to study tick-borne diseases in New York City? So here's Staten Island. Many people here in New York haven't been there, and it's very, very different from the rest of the boroughs. So there are a lot of parks with high connectivity, and they have an increasing deer population that they arrived like 10 years ago, and that's just exploded. And basically they swim over from New Jersey, and they're bringing ticks with them. So this is a map of Lyme disease incidence through the island. Basically deer are coming from here, that's why you see, and these are the high density parks. But basically in the last 5 years we have seen an increase on tick-borne diseases, especially Lyme disease, and people are really concerned. So what did we do this summer? So we have a limitation, is that the high-risk season goes from May to July, and so we have the limitation to collect the data. We have to go through that at that time, and that's what we did. So in May we did some focus groups that allow us to develop the KAP surveys, and in June and July we did the household surveys. We collected the ticks. In August we did sampling of mice, because mice are the ones that give the infection to the ticks. So we wanted to know if there were mice to sustain and infect ticks in people's backyards. And at the end of September we did a retrospective tick exposure, so through the app. So we asked people if they had been exposed apart from the app, which I'm going to talk a little bit more now. So this is what we found. We visited 500 houses. We actually we were able to survey 130, because most of the people were not home or they didn't answer, which is about what we expect. And most of the people that answered the door wanted to participate. And we found ticks in a third of the houses that we visited. But we wanted to understand, again, how human behavior and tick exposure. So the question was, which activities increase the risk of tick exposure, and where do people are exposed to risk? So this is typically collected through retrospective questionnaires. We have a lot of problems. The main problem is that they have recall bias, so we don't know. People don't really remember. There's a lot of uncertainties, and there's a lot of limitations for external validity. So you have to do it in many places to be able to have a sense of what people are doing and its heterogeneity. So basically we decided to do a smartphone app, and that's because we can collect a lot of data. People don't just have to download the app, and people use apps all the time. So it gives us the opportunity to reach more people and to collect data that we could not collect otherwise, like human mobility data. So this is the timeline of the development. Basically we started last fall. We did last summer, so the previous summer 2017, we did a pilot app which was called GeoQuestion. Based on that, we developed the new app, and then we launched it last May. But basically, the app has this layout of the homepage. You have the tick diary, which basically we ask people on a daily basis at the end of the day what they did that day, if they found any ticks on themselves, and if they used any protective measures. We also ask them if they found a tick to report the tick, and we have pictures so people can identify, so we know which type of tick it was, and we ask them to submit a picture. And was this educational material and how to identify a tick, and we also collected mobility data using the location services. So where were the baseline, the people located? So this is a nationwide, so it's available. You can download it, it's free. You can find it in the App Store or Google Play if you have Android. And most of the people were based in New York and New Jersey area, but also in Wisconsin, because this is a collaboration with people from the University of Wisconsin, and they were recruiting people there as well. We're trying to compare human mobility patterns between the Northeast and the Midwest as well. And this is a sample of the human mobility that we're starting to analyze. So I just got this data, so I'm in the process of analyzing it. Basically, half of the users only interacted once, and they didn't completed anything, but half of the people engaged with the app, and they interacted with it with a median for 24 days. And this is the most interesting thing, is that the profile is, we have 50-50 gender ratio, which is great for us, because it's usually this surveys are usually biased toward women, older women. So being able to have an equal ratio is great for us. And also the age distribution, we have a bimodal distribution, but we were able to reach the younger people as well. 30 of people reported to have previous tick exposure, so the sample might be a little bit more biased towards the people that were already aware. And we were a little bit worried about the daily surveys and if people were going to actually do it. But it was actually, when we look at the people, how they interacted with the app, the tick diary was the one that was mostly used. Basically, when we went to people's houses, we actually asked them to download the app and show them how to use it. And we were able to collect 2,500 daily surveys. So most of the people did indoor activities only, but a lot of people did a lot of high risk. All these activities that were listed in the app is activities that we previously identified as high risk. And what we have, people reported 5% of the tick diaries reporting to have ticks themselves or ticks on pets, which is typically what we expect. And these are the longitudinal tick report data from during the summer. So with this, we hope to collect, as I mentioned, I just got this data, so we're trying to extract activity patterns for the population and the mobility patterns with using the location data. And this is going to feed the agent-based model, and the outcomes of the model will be human tick contact rates and Lyme disease incidence at a local level. And we also want to understand how the ecological context and over time and risk perceptions change risk perceptions and change activity patterns. So we're going to continue for another summer. So this is it. Thank you very much. I went a little bit over.
No, you didn't. By being ruthless with questions, I've actually got us slightly ahead of schedule, so we can take questions on this talk and others later.
Yeah, definitely, and that's one of the limitations. So, and I mentioned that a lot of people that engaged with the app were people that were already self-aware of the tick-borne problem, and we also want to capture the whole population mobility and activity patterns. So, what we want to do is engage people that are not as worried about ticks. So for that, we need to think about other incentives, and we're going to think about maybe economic incentives or some way of make the app turn it into a game that they can have some kind of reward. So far, the reward they have is like if they find a tick, they report it to us, and we actually get back to them and tell them what type of tick it is, if they should be worried, and some recommendations about what to do. Yeah, that's definitely a challenge.
Are you thinking of, I don't think I heard you talk about Lyme disease. Are you distinguishing the ticks in that sense?
So I'm focusing more on tick contact rates, but definitely Lyme disease is the most important disease in the Northeast. So I'm focusing, actually on Staten Island we have 3 tick species. One is like obviously the black-legged tick, which is the most abundant, the most common one. But you also have, there are certain areas where you have the lone star tick, and there's a new, actually this summer we discovered that there's a new invading tick on Staten Island, which the problem with the last 2 is that they're very aggressive and they look for you. Well, black-legged ticks, they're just hanging out there, and you brush against them, and that's how you get them on. The other ones, they actually look for you, and they go towards you. So that's why when we ask people if they found a tick to report it and send us a picture so we can actually distinguish about the different ticks. But for now, it's because people are not really good at identifying them, and they have the same risk factors. So activity patterns are going to be the same. And so we're more interested in human contact rates and then distinguish the ticks ourselves.
What you had said earlier, but I'm wondering whether or not the deer population is significant as a vector.
Sorry, I didn't hear.
The deer population, is that a significant vector?
So the deer population, what it does, all the adult ticks need a big mammal to actually feed upon, and that's where the female and the male, they mate. So you need a big mammal to support a tick population. If you don't have a big mammal like deer, it could be horses too, but deer, because deers are so abundant in the island, that's where they are feeding on. So if you control the deer population, then the tick density is going to go down because the adult populations don't have anything to feed on.
Deer prevalent in Staten Island?
What is it?
Do you find deer in Staten Island?
Oh yeah, everywhere. It's a huge problem right now. And the problem is that they can't control it as they control it in other places through hunting because it's an urban area. So they're doing deer vasectomies. But the impact of that is going to take longer to see. And also it's not a closed population, so you have deer coming from New Jersey. And so the deer control is a challenge, but it's not the only solution that we can implement.
So I am well aware of the problem in eastern Long Island, particularly Shelter Island.
Yeah.
Is that someplace you've noticed?
So all the islands around the Northeast have a huge problem because they're close populations where deer have exploded basically, and so they are very highly endemic. And there are things that are being done. Most of the islands they control deer through hunting because they're not highly urbanized, or they do the deer post where they kill the ticks on deer. But there are other concerns about that because of basically you're feeding deer at the same time, so that creates that you're increasing the population and you're giving them resources, and so there's an issue with that as well. And then you have to lower the deer population to really low density levels to prevent the tick population to be sustainable.
Do your studies pose a mitigation?
What is it?
Does your study pose a mitigation?
So what we're proposing is, so the agent-based model is to try to analyze different integrated vector control measures through spraying, controlling deer, but all this combined control measures, what's the impact that they're going to have in people's contact rates. So the deer population is going to be just one measure, but it's not going to be sufficient by itself. So if you do spraying at the same time and you control the mice population, what's the joint effect that it's going to have in reducing tick exposure?
Okay, thank you.